We are the Penguineers, team 11454, and here's a quick engineering tutorial from our top engineers.
So the first thing you want to know about your robot when it comes to engineering is cohesion. You want to make sure all the parts work together simultaneously. Although sometimes you can design parts separately and they all work individually, you have to make sure they all work on your robot together and that one part's really not holding you back, making your robot as a whole fall back and make sure everything's not working.
Next thing I want to talk about is planning, drawing, and using CAD softwares. One big stepping stone for the Penguineers is making sure that we always CAD everything before we develop it and have a good discussion with our team about each of our design parts. So each choice would routinely be discussed in a program called Slack, which I recommend very much if you guys are struggling with communication. We use Onshape and SolidWorks currently to design certain parts, and for planning, we like to usually use whiteboards or just a general discussion to the entire team about what our robot plan will be for the next game or anything really. Just making sure that our entire team stays informed throughout the process is very crucial here.
A good way to do that is through a dedicated brainstorming meeting. A good thing to do before you go on a weekend build or start building in general is have a good 1, 2, maybe even 3 hours to think everything out, devise strategies for the game, and think about the best possible way to go about engineering your robot. Because if you don't do a meeting like this, it can sometimes hold you back and you really don't have the best ideas and everyone's input really isn't involved. So it's best to have a brainstorming meeting so everything works the best, is most efficient, and is all worked out before we go on and start building.
And to build on that, whenever you're building, you want to make sure that you're using the right parts for each specific task. One example of this is servos. Servos and motors are very different in their applications. Motors are going to be what's used for your general driving and heavy lifting on the robot. Servos instead are more precise. They use angled coding for each precise turn and are not as powerful as motors. So for motors, you want to make sure that you're using like more torque applications, and servos are going to be for those more precise things with the game.
Another big thing to recognize when it comes to engineering robot is driving. I mean, you have to engineer the robot, and it may be the most perfect robot, but if it's not in sync with your drivers, you're really not going to do the best. You want to make sure your engineering and your building is built perfectly to their needs and their specialties as drivers. And another thing with that is the form factor and the speed. A lot of things that holds people back is when the robot just isn't fast enough. Their intake may be good and it may be like working well in theory, but when it comes to the actual field, it just works too slow. So you gotta make sure your robot has the right form factor, is perfect for your drivers, and has good speed. An example of this would be this year, the garage doors. You wanna make sure your robot is under the height of the garage doors because it would be a hassle for your robot to get around it otherwise. Making sure that your robot has the most efficient pass and your driving can be as efficient as possible is best for overall engineering design and point scoring within Centerstage this year.